Hi everyone, I wanted to go ahead and cover an example pertaining to the material that you looked at today for 7.3 and 7.4. Specifically, we are going to work with probability trees, and we are also going to work with the definition for conditional probability. So I will go ahead and include that information in this video. What I would recommend is having a notebook out in front of you, or at least a sheet of paper, so that you can follow along and take notes. So what we are going to go ahead and do is we're going to take a look at a market research question. Okay, so I'm going to keep this pretty bare bones in the video, so feel free to make sure that you are taking good notes so that you are aware of each of the pieces. We're going to go ahead and take a look at two potential events here. One of them I'm going to call R, and this is going to be the event that someone responds to a direct mail marketing campaign. So just in case you need a little bit of background as to what that is exactly, think of your favorite store that you like to shop at, or your favorite restaurant that you like to shop at, or eat at, I guess, more appropriately. These individuals will somehow get your information, maybe from you swiping your credit card when you purchase something there, or maybe you give them your email address or your mailing address or something along those lines. Direct mailing means that they are going to send you offers or advertisements for their services or their products directly to your home. Okay? So that is what a direct mailing campaign is going to be. They're going to send information directly to you in hopes that you will respond. The other event that we're going to look at is going to be event C, and that's going to be that you have a credit card on file. So if you go to pretty much any big chain store or chain restaurant, they may have some sort of credit card that you can apply for and then use at the store. Companies enjoy doing this, or enjoy getting their clients to take this, because then that means that they can avoid paying any sort of credit card transaction fee from companies outside of them. So we're going to have these two events, and what I do want you to know is, or maybe ask the question, are these two events independent of each other all the time? And hopefully your gut reaction is, well, no. If, for example, I have a credit card on file with my favorite store or my favorite restaurant or the gas station that I frequently go to and use, they're probably going to also be sending me advertisements for sales and specials and services. So these two things are not going to be independent. Odds are one could be causing the other. So what we are going to go ahead and do is we're going to work with these two situations, and I want us to figure out, okay, as a market researcher for a company might just be interested, well, what's the probability that our ad campaign is just going to, what's the probability someone will respond to our ad campaign? Okay? And we are going to solely focus on people with credit cards with us and people without credit cards with us. So that means that in order to determine the probability that anyone is going to respond, I need to look at the probability that someone is going to respond and they have a credit card with us, or the probability that someone is going to respond and not have a credit card with us. Okay? So because we've broken this up into an either has or has not, when we add those two probabilities together, we are covering the whole gamut of who could potentially respond to us. People with credit cards could respond to us. People without those credit cards could respond to us. There's no one else that we're leaving out. We've covered the entire population that we're interested in. The main issue, though, is, for example, we may not have this exact information. And especially since the fact that these two events are not independent of each other, specifically the event of responding to an ad campaign and the event of having a credit card on file with the company, it makes it a little bit harder. Okay, so we wouldn't necessarily be able to pull that information up. So what I'm going to go ahead and do though is say that, well, maybe we do have some information, and I'm going to go ahead and write it over here on the right side in black. And I will tell you, for example, that the company should probably know the percentage of people on file, or the percentage of maybe people in the area that have a credit card with them. So let's say that we know that the percentage of people who have a credit card on file with a company, maybe in this area or this city, in our hypothetical situation, is 38%. And maybe they also can tell you, well, we know that the probability that someone is going to respond given that they have a credit card with us is going to be 28%. They are probably going to be interested. That's an issue for them. They have a credit card with us. Why aren't we getting a higher response rate? They may also kind of look at the negatives. So the probability of not responding to an ad given the fact that an individual does not have a credit card with them. And, we'll say that that's going to be a whopping 90%. Where I'm getting these numbers, again, these are completely arbitrary. I'm just saying that this is the data, or these are the statistics that this company is giving to you as a market researcher. And you will be able to use this information in order to just tell them the probability that someone will respond to their direct mailing campaign. So getting back to what we have over in red, I don't necessarily know what the probability of R and C is. However, recall that we do have a definition for conditional probability. Okay, so for example, the probability of R given C is going to be equal to the probability of R and C, so the probability that both of those events are occurring together, divided by the probability of C. Okay. Please recall that our given situation here, C, is also going to be populated in the denominator here. That's not a coincidence, that's actually intentional. That's how the definition is constructed. That being said, if I'm more interested in figuring out, okay, I'm going to create an equivalent statement here. So with what I have boxed, the probability of R and C. Notice that that same probability is located right here in the numerator of my definition. What I'm going to go ahead and do is I'm going to multiply both sides by the probability of C. What that will allow me to do is clear out the numerator and denominator on the right-hand side. And lo and behold, what I have here is the probability of C times the probability of R given C is equal to the probability of R and C. So what I'm actually going to go ahead and do then is I'm going to take this, what I have on the left-hand side, and substitute it in for the probability of R and C. I'm just going to swap out those two probabilities, because if you notice with what I have in black, I know what the probability of C is, and I also know what the probability of R given C is. Okay, so I'm going to go ahead and jot this down. So again, what I'm doing is I'm just doing a substitution. I know that an equivalent statement for the probability of someone responding and having a credit card is going to be the same thing as the multiplication, or the product, of the probability of having a credit card times the probability of responding given that you have a credit card. What I would suggest doing is, for the second half of that addition problem that you see up there, maybe repeat what we have written over on the right-hand side and see if you can construct what that substitution would look like. So pause the video, and once you're done, come back. Okay, I'm assuming that you did pause the video and make an attempt. So if we were to write an equivalent statement for what we are looking at for this second portion of the addition problem, this is going to be the probability of not C times the probability of them responding given that they don't have a credit card. Okay. So all I've done from the first line that I'm going to go ahead and star here to the second line is I've done substitution. I've rewritten those two probabilities so that each is a product of two probabilities. I was able to do that by using the definition of conditional probability. So the next issue is, well, I need to go ahead and determine what these values are equal to. And like I said, this is basically going to be a drop down in a sense. I know for the probability of C is 38%, and we would convert that percentage into a decimal. The probability of them responding given that they have a credit card, I know that information too. That's going to be 28%. So here, I might be able to figure these two portions out. If you're not seeing it, I would suggest pausing the video and creating a probability tree. And what I'm going to go ahead and do is I'm going to create one now, and I'm going to fit it right in the center here. So I'm going to create my probability tree. So I do have my first set of branches. And how this is going to go, given the fact that I do have the probability of R given C and the probability of R not given C, it looks like the first event that needs to happen in this situation is if you have a credit card or if you don't have a credit card. That's the first event that has to happen before they can respond to you. Okay, so I do know that in this situation that the probability of having a credit card is 38%. So I'm going to use the complement and say, well then the probability of not having a credit card with the company is going to be 62%. And again, the complement is where one probability plus its opposite, or its complement, they should sum to 1, or in other words, 100%. So we're going to continue on, and we're going to generate two other branches, each off of the credit card, and then for the not having a credit card one. And this is going to represent, did you respond? Did you not respond? And again, in that situation, we might have a, did you respond here? And did you not respond here? And I have some of that information. I know that if you respond given that you have a credit card, that's going to be 28%. And I know that if you did not respond, given the fact that you did not have a credit card, that's 90%. So the only thing that I have left to do is fill in those missing branches. And again, I can use my complement rule here. So 1 minus 28%, that's going to result in 72%. 1 minus 90%, that's going to result in 10%. Okay. So now I have the information that I need here. Okay. So I'm going to go ahead and note this in green. Okay. So I know what the probability is of having a credit card, and that's 38%, and I've actually already noted it here. The probability of responding given that you have the credit card is 28%. So that's what I'm going to put there. The probability of not having a credit card, that's going to be 62%. So that will go here. And we're going to multiply that by the probability of responding, given that you don't have a credit card. So that is going to be 10%. If we take care of the multiplication first, remember we are doing order of operations, this is going to become 0.1064 plus 0.062, and if we add that up, that is going to take us to 0.1684, or in other words, 16.84%. So what does this mean then? Well, we're saying the probability of getting a response from the mailing campaign is 16.84%. So it doesn't seem like they're getting a very high response rate. Okay. And remember, this is in general. I'm not concerned as to who specifically is responding, meaning whether they have a credit card with me or if they do not have a credit card with me. I'm just saying the probability of you responding in general to my direct marketing campaign is a little bit under 17% in this case. So another good question to ask would be, well, how do I know that my calculation is correct? How do I know that 16.84% is the correct answer? Well, we would have to do a little bit of extra legwork here. Okay, so what would happen? Let's talk about the following in green. I know that the probability of getting a response would also be equal to the complement of not getting a response. So in other words, my probability of getting a response, I can find its complement. Okay, so subtract 1 from both sides, and this is going to give you negative 0.8316, which is equal to the negative probability of not getting a response. So in other words, if we were to, again, divide by negative 1 to clear that negative out, then the probability of not getting a response is going to be 83.16%. Well, that is based off of our calculation for the of finding the probability for a response. Let's actually start fresh. And I'm going to just move this up so we still have the probability table in view here. Okay. So let's determine the probability of not getting a response. If we do this the longhand way, we should arrive at the solution. If we get something different, then it means that somewhere along the lines, maybe in our probability tree or maybe in our calculations up above, we made an error. Okay, we should be able to calculate the complementary probability. So if we do this the long-handed way, we would say, okay, well, this is the probability of having a credit card and, let's see here, not responding, plus the probability of not having a credit card and not responding. Okay, so again, I've covered all of my bases. I've covered the situation that someone could not respond and have a credit card with me, or someone could not respond and not have a credit card with me. Good. So again, using our definition of conditional probability, we can break up or rewrite these two representations. Okay. So the probability of having a credit card and not responding is going to be the same thing as having a probability of a credit card times the probability of not responding given that you have a credit card, plus the probability of not having a credit card times the probability of not responding given that you do not have a credit card. Okay, I'm going to go ahead and denote our pathway in blue using the tree. So again, the probability of having a credit card is going to be that 0.38 times the probability of not responding given that you have a credit card is going to be that 0.72 plus the probability of not having a credit card is 0.62 times the probability of not responding given that you do not have a credit card is 90%. Again, if we were to go ahead and take care of this using our order of operations, we would get that 0.38 times 0.72 is 0.2736, and 0.62 times 0.9 is going to be 0.558. If we sum this together, we get 0.8316, which is 83.16%. So again, notice that this value matches. So it's a longer way, but if you really are not certain if your calculation is correct, you can verify. Okay, because those two equal each other, you have a higher chance of you actually doing the solution correctly. So really quickly, because I know this video has been pretty long, I'm just going to take you through this really fast. Okay, so the notes that we have in black in the upper right-hand corner was information that was provided for us. What I wanted to note was the probability that someone was going to respond to me. So that means I had to take into account someone could respond to me and have a credit card with me, or someone could respond and not have a credit card with me. that information, those particular probabilities that I have listed on the right-hand side over there and boxed, I don't have that information. However, I can kind of use a backdoor in order to calculate the probabilities. So I use the definition for conditional probability to rewrite, for example, the probability of R in C to be the probability of C times the probability of R given C. I deliberately chose to construct my definition in this way because I have those probabilities already provided for me. So definitely construe that definition so that you can have it work for you and that you don't have to do any extra calculations or legwork. I did the same thing for the second portion, and then I could either just use the complement rule in order to find out all of these probabilities, or I could use the probability tree to kind of graphically organize my information. I dropped those in, took care of my multiplication and my addition, and then I got my final answer, which was the 16.84%. And again, this is verbally what we are seeing is our result. And then finally, you could just go straight to the probability tree in order to construct the multiplication and addition signs here that we have. That is also possible. You do not necessarily have to write out all the notation in those two previous steps that you're looking at. So I hope this helped. If you do have any other questions or if you need anything clarified for you, please come see me or seek out a tutor.